and the data, building the models, testing it, and then doing that over and over again until you get an objective result, and then casting that result down.
But if you don't have run to failure data, you're not going to get good outcomes.
I could also see a privacy issue with cloud that you would have to, you're outsourcing the privacy in that context, especially with manufacturing. That means just be faster to do it on-prem.
If you need that faster sub-second on-prem response time that you're speaking to, what I've seen in the solutions that we ran in the cloud, even in the healthcare solution, we're talking seconds.
Like digital twin, you just have, a fake environment, but you can play with the information.
Digital twins are a little bit more powerful, and it gives you the ability to simulate.
Because the errors come spontaneously in these environments, it can mess up your data because getting these models to actually give you the results, it does take time. You have to train it for a period of time.
So if you have capital equipment for 50, 60 years ago, you can put translation layers in there to get that digital information. But you got to keep in mind that the equipment can only do so much.
Hey, Kyle, how are you doing?
I'm doing well. Good morning, Ihatu. How are you?
Good morning. I'm okay. How are you?
Doing good this morning. Thank you.
Fantastic. I'm going to introduce you here a little bit. So, and correct me if I say your name incorrectly, but this is Carl Neely.
That's correct. You're absolutely correct. Yeah.
Thank you. And he is, among many things, a senior manager of AI and machine learning at TAMCO. Is that correct?
That is correct.
And he's actually been in the industry for a very long time. Worked at different companies, Blue Cross. He's been a project manager, and a senior IS specialist at Toyota and John Deere. So, from what I'm seeing from that resume, he's been in a manufacturing industry for quite a few years.
That is correct.
And he's also been in healthcare as well. And he's here to basically talk a little bit about both those things. So thank you so much for joining us.
Well, thank you for having me, Haupt. I'm super excited to be here and to share my experience with you and your audience.
Thank you so much. I'm going to start off with asking, basically, what's your day-to-day like as a senior manager at TAMCO? So what does it mean to be sort of have that responsibility tier, and how do you sort of provide value on a day-to-day basis?
Yeah, enjoying TAMCO, one of the opportunities there was really to lay out the foundation of what should the AI and ML strategy look like from a long-term perspective. And so a lot of that first started out was laying out the strategy. How do you integrate that into our production building process? Because there we make building materials as an example here. And so really a day-to-day looks like hey, here are all the critical use cases that we have to execute that strategy, where be it for predictive maintenance to vision systems, identifying defects, to those sort of things. So it's really about now the execution side, now that we laid out what that strategy is. And just in general, we're looking towards, without getting into specifics, we're looking towards the autonomous operations here. So analogous to what you see in vehicles, for example. How do you get these processes to intelligently run with little or no human interactions? And that's really the aspirational goal there.
Right. And so from my understanding, vision systems, I'm assuming you're using a little bit of robotics as well to be able to facilitate all these in order to sort of eliminate the need for, in a lot of cases, kind of sort of dangerous things that a human might have to do. We had someone on who was working in woodwork, AI and woodwork, which is quite a unique thing, but it is manufacturing, sort of identifying defects and things like that. Is that something similar to what the strategy is in the organization?
Yeah. So one of the things that in particular that we're focused on is improving that product quality. And so typically use that by using the vision system to identify these defects on our roofing products as they move down the assembly line. So you don't want that to get shipped to the customers, of course. So you could scrap that, or if there's an opportunity to fix the material before it goes out the door, you have that that opportunity to do that. So our application, some of the general use cases around that is defects detection as one, and then another one is around safety. We're using ours mainly in the aspect of defect detection.
Right. Okay. Well, I wanted to ask you sort of personally, what made you get into ML and AI? It's only become popular now. Because some of these things have really become really interesting, and people have been able to interact with products in the market that primarily use the abstractions. But I mean, what was it like to sort of get into this early on in your career?
Yeah, I always been in the technology space, for over 25 years, but it started about 12 years ago when I was working in the healthcare vertical there for Blue Cross Blue Shield, and I got an assignment where I was working with some statistical actuaries to do predictive models for readmission. So in healthcare readmission, you think of that that's a defect. You have a 15-day readmission, a 30-day readmission, you discharge a patient, things like that. And so working with them really got me excited because I was on the track to management, kind of a little removed from the hands-on and the technical aspect of it. And so that project 14 years ago gave me an opportunity to get the hands-on work with the actuary team again on designing that. And so that really sparked my interest. I started taking training and classes, certifications, learning more about machine learning. And here I am today. It's really excited. And that project was quite fascinating because working with a team of actuary, they really statistically based. So it was basically logistic regression, all these, statistical terms, p-values, we got to do confidence intervals and things like that. It was actually pretty successful. We applied it to a population where we were able to, I think the accuracy is about 70-ish or so, but that was good enough for us to predict if a patient would be admitted with these attributes, for example, or this profile, that there's a high probability.
70?
Yes, 70%.
Is it 70 people?
No, the accuracy was,
70%.
yes, the accuracy was 70%.
Oh, this accuracy is 70%.
Exactly.
Okay, got it.
Yeah.
Okay.
So that was pretty good because we can able to identify people, what we call high risk for readmission. And the easy address to that is having our clinicians now reach out to those people, work to those people that are being discharged from the hospital to make sure that they have the proper care outside of the hospital, and discharge planning, like a caregiver, a loved one, or family member, can help them so they won't go back into the hospital prematurely, like on a 15-day or 30-day readmission, as an example.
Well, what were the properties of the people who had the tendency to be readmitted? So what were the characteristics that the model was able to identify about because it's such a, I want to say it's such a personal thing, but not to be cliche, but it's, how do you identify a person's mental tendencies if they are mental, and if it's not, if it's just an issue with the way that the care was done? That's also difficult to do.
Yeah, that's a great question. So what we found in the analysis of the data, so the data set we looked at was, you can think of a different class. So we looked at the demographics of the individual. We looked at the historical medical records, the procedures in which they was in the hospitals, and the hospitals themselves, or the facilities that they were in. So we looked at a combination.
So those are the variables.
Yeah. So we looked at a combination of those, and we found some of the stronger predictor variables of a readmission is race and gender as one of them.
Indeed.
Also, we found hospital facilities too as well as another great predictor here. What we didn't find is a lot in the healthcare space. A lot of treatment plans and procedural codes, even though they're standard, they still vary. And then, like what you pointed out, it depends on the individual how to respond to the treatment, right? When you look at healthcare, you do the cohorts, right? But it's really about the individual how to respond. So really, the demographics, like again, the gender and actually race as well. And then the hospital facility tend to be the stronger predictors of the readmission. We did not look at mental health clinicals because usually when you talk about HIPAA, they try to keep those separate unless you have permission. So your physical health information or practitioner information is separate from your mental health unless you give permission to combine that. And that's actually one of the challenges of some of our HIPAA laws too as well.
You would have preferred to have that. I would assume you would prefer to have that data to be able to. You think that would have provided you with a higher level of accuracy? Because 70% is honestly is quite high. But you think that mental health would have provided you with maybe 80?
I think so. I think the medical professionals, really the doctors and the nurses too, would prefer that. But again, you have to get permission to apply that to your population. If you don't have that permission, you just can't. We have a principle when I work, they have called medical necessity. So you only can grab as much data as that medical necessity for the application or use case of which you want to pursue.
Right. Oh, okay. Fair enough. So, you know, another thing I wanted to ask you was, just switching back more to a leadership perspective, right? Well, but even before I do that, if I could guess what gender was more likely to go back or be readmitted, I would guess male.
That was actually women.
No way. I thought it would be male. Is there a reason for that? It's just the outcome of the data.
It was hard to get down to the root cause or why it would be female, but the population that we were looking at that we applied to. So in healthcare, they got different type of what we call business population segments. So we were looking at Medicaid and Medicare type of populations that we applied this to, and it actually turned out to be women. There was more women in the set too as well. So right, and so you have that bias, but that still is a strong predictor of the data as well.
Yeah, you still need to, pay it. As a consequence, you still need to pay that attention because
you can't. You just can't ignore it. Yeah,
it is what it is.
Mm-hmm.
Yeah, fair enough. Okay, so going back to sort of stepping out of that and moving more into your current day experiences. So, moving back into the idea of being a senior manager. So, do you have people under you, and sort of, if you can you talk about leadership and even if you don't, sort of engaging with other people in different departments, trying to explain. Because a big part of this is like, how do you explain what you do to other people, and understand the value of it if they're obviously not trained in it, and how do you communicate your ideas?
What's fascinating about being in the senior manager role here at TAMCO is that it's really a combination of setting the vision and the strategy, and then the hands-on aspect. So you get a little bit of both. And I have a team that report up to me as well. My team is about 3 people that report up to me, and really what that looks like is, when we lay out the strategy, what are the tool sets, the technologies that we need to pursue this type of a strategy. And so it's about, working with our senior leaders. In that case, I work with executives on almost a daily basis, laying out, okay, what is the business case to pursue this? Do we have the right use cases? And then not only that, the equally important piece is skill set. Do we have the right type of skill sets to pursue the strategy? So a lot of it also is upskilling. I run the community of practice, for example, to upskill our broader community of people that use our AI ML tools and platforms. We use a tool called Readmissions, for example. It's an AI ML auto ML tool that we use to train our community of practice folks on how do you apply this daily day, engineers, as well as analysts, data analysts, et cetera, on how to use the tool to solve real business problems. So it's a combination of the hands-on and then laying out that strategy. What do we need to do from a investment perspective? Are we focused on the right use cases? And probably understand this, that depending on research you look at, that 50 to 60% of AI ML projects and solutions just never make it to production for whatever reason, and that's a high failure rate if you think about it like that. But it's that experimental nature too that you have to deal with, and have to understand that, hey, this is a learning process. So you have an element of cultural change there too as well. Some people maybe used to say, well, it's our reports are successful. It's like, well, we're not dealing with reports here. We're dealing with the highly experimental AI ML solutions. And can you find the right signal through the data? Do you have the right type of data to find the signal to do what you want to pursue with the solution? So it's a lot of that, and it's fun and it's challenging. And really, like I said, our aspiration is autonomous operations. How do you build those continuous processes that continuously feed data from an environment, analyze it, make a decision based on that, move some equipment independent of people, and then take that information and self-assess and reflect, just like you and I would, to make sure that was the right decision. And so,
so what would you consider the cycle to be for this? So 9 months, a year to sort of move the organization, and obviously it's different for different organizations, but move the organization towards a place where they're prepared to make the implementations ready. Because it is, getting the data is one thing. It's a huge part of it, getting the data, building the models, testing it, building the infrastructure to test it in a way that doesn't affect business process. And this is what I'm understanding from what you're sort of explaining. and then doing that over and over again until you get an objective result, and then casting that result down. You're almost building you're building a pipeline of outcomes throughout the organization. A lot of those pieces are not necessarily in your control, specifically the front end and back end of it, essentially, right? So, or you can flip it the other way, the back end and front end of it, actually, because the front end is the outcome. So both those sides, you need a lot of support, and that does take time. And then building it takes time, and then testing it takes time. So what do you feel like, just for people who are trying to do this, and what is the point where you should have an expectation that something should have an outcome and not get frustrated? Because that does happen a lot in large organizations. People do get frustrated about not having support.
Right. Excellent question. And really the answer on working in various organizations, two verticals, healthcare and as well as manufacturing, really depends. So let me give you an example of healthcare, then I give you an example in manufacturing. So in our journey to the work at Blue Cross Blue Shield, in that journey, we're talking about, hey, how did you basically institutionalize these solutions and help the organization understand how to apply it? So in healthcare, the standards are very high. And so that iteration cycle and process have to be very good. Otherwise, a doctors or clinician nurse is not going to trust it and accept it. It's not going to be something that we can apply to help inform a person's healthcare choices and decisions. What I'm happy to say, though, that Blue Cross Blue Shield been on their journey for quite some time, so they understand risk, they understand statistical analysis. It was just moving them in the direction of now applying more powerful tools like machine learning. So when I worked there, we worked on a system, a natural language processing system to automate the reviews of medical records there, we had the foundation of places. We had our data, basically engineering teams. I was basically what they call if you think of the agile model, I was the product owner that reported up to the executive team. Yeah, exactly. And so in that case, we had the foundation. We had the data engineering team. We had the IT application team. We actually had a startup vendor too that was responsible for actually building the solution for us. And then we had a data science team. So we had all the pieces in place. So there wasn't a really strong lift from a cultural perspective that we had to put in place for that. And so we were able to iterate on that solution, and we were able to actually get a working prototype in place within literally like 4 months. And that is lightning speed.
Incredibly quick.
Yeah, that is
quick.
lightning speed. Whereas at Tamco and working there, it's a greenfield. We're just starting out. And so some of the foundational things that we had to put in place there is we had to say, hey, how do we identify what kind of tool sets we need? And we went through a proof of concept, looking at different AI ML platforms, the engines, cloud-based platforms, we consider Google, Microsoft, and a few others, SAP, looking at those different. So now you have the time there, and really to get the foundation in place, you're looking at your data foundation, technology foundation, also building the business cases to get these tools. That, hey, in order for us to execute the strategy, we need these type of tools. So that in and of itself took about, well over years. And when you implement, put at least the foundational tools, now you got the upskilling piece that you have to put in place for the folks. We have a new tool. You have the upskill people on the IT team, upskill the data analysts, these engineers that we work with, those type of things. So that takes time too. And then the iteration cycle in that space is really about, now that you have it, do we have the right data? Do we have the right use case that we need to focus on? It's so easy to say, well, hey, let's maybe pursue this predictive maintenance. But if you don't have run to failure data, you're not going to get good outcomes, right? And so you got to do those type of assessments up front. So the iteration cycle in manufacturing, the data is a little bit different, but the iteration cycle is really about, can you find the signal there at that point? And so those cycle times for us looking basically more like, anywhere from 3 to 5 months. And then we have criteria, we call it the kill criteria. We have criteria that if we can't find the signal, we identify we don't have the right data, or the solution is not better than what we have today, then it makes no sense from a business perspective to pursue it.
So signal, and correct me if I'm wrong, I'm understanding signal as identification of net positive outcome? Is that, or is it something else?
So signal is specifically the relationship of the data that you're looking for. You're trying to find a signal so you can predict something or you can classify something, right, in the data. And so if you think in the industrial space, we're dealing with all these different sensor devices. Yeah, heat sensors, vibration sensors, those type of things. And you bringing them together and you try to find a relationship between them, right? And that's what we talk signal, right?
Got it. Okay. So are you basically looking for correlation, which makes sense because it is an ML model.
Yeah.
Right. Okay. So, and I'm assuming I do almost wanted to go down the road of like, how do you gather all this? What are the tools for gathering all the information from all these sort of IoT devices, right? But I'm assuming that's all kind of there. You just you sort of tie into an existing a data pipeline system that the people must already have built before you got there, or or they found the need to actually bring in an AI expertise.
Yeah. So we do have we manufacture execution systems that collect this data from these different sensors and devices that tell you basically, in general, how this piece of equipment performing relative to the production process. So we do have that as a foundation. However, it's not contextualized in a meaningful way, right? It's just data there that's collected. Like I said, the relationship, you don't understand this relationship with this sensor to that sensor. I think we have very smart process people that understand the relationships in general because they're responsible for running the process. But you really don't know, depending on the use case you want to pursue, if you got the right type of relationships and if you can model those right type of relationships. A lot of things you pointed out, you talk about correlation. A lot of things are historically you look at, linear correlation things, but a lot of relationships are not linear, especially when you're dealing with different.
Almost none.
Yeah, that's right. You're dealing with different equipment manufacturers from different decades, really, because some of the capital equipment is old. It's like some 50, 60 years old. And so you have these external sensor devices. So how do you bring that all together in a conceptualized, meaningful way to find the signal where that you can say, oh, yeah, for sure, these are great predictors where I can, I can predict the temperature 10 minutes in the future using a time series model so that if that temperature is off, I can make an adjustment to a machine to make sure that I can avoid it. So it's like you and I, we driving down the street, we see the pothole coming up. And if we see that pothole, if I see it, I can avoid it. And so that's one of the strategies that we employ too as well.
That's quite a granular endeavor. Like I just, to do all this and all these, because there's a growth of complexity every single sensor you add, and under the assumption that not all sensors need to actually integrate with each other, but that work can grow quite exponentially, especially if each sensor is doing a different thing. There's a lot to talk about there, but I do want to move on to data privacy, because I know you're in a unique position to talk about that. It's also a concern for a lot of people, especially with some of the new developments in AI. But because you worked in healthcare, and that's something that data privacy is absolutely essential to make people feel comfortable. It's a big part of the organization, both as customers or even as from a more point of view as people who are working in there. So could you talk a little bit about that, and either your perspective on that, how your experience with that, and see just to explain to the audience what that was like.
Yeah, so data privacy, and you think about it in the healthcare space, is really about complying with our HIPAA laws when it comes to your healthcare and medical records and history in that case. And so a lot of when we pursue our AI ML solutions, like when we built the natural language process to review medical records, we had to be HIPAA compliant. And so that's additional constraints that we have on that. So in some cases, when we build the models, we have to amortize that data, right? We got to basically strip out the names. Exactly. Strip out the names and those type of things. And then depending on the use case, also, we have to treat what we call protected attributes different. So protected attributes is like what I mentioned there is like race, age, gender, those type of things. Those are allowed in particular use cases that you're trying to solve for, because they are important, but also you can't use them in a way that can be biased or discriminate. right, in your data set. And so you have to deal with those factors, especially when you come, like I said, to healthcare data there. Now, when you're talking about data privacy in the manufacturing space here, it's more about proprietary secrets and processes and recipes. Like, for example, Coca-Cola, they have a proprietary recipe and secret. That's protected. You have to always have the security around that as well. And there's security protocols that we have in place to protect that data. On the HIPAA side, there's protocols like FHA Fire, FHA 7. These are all and these are integration protocols that also add a layer of protection on top of it too. And then,
And what did they strip out or transform? Is it then an encryption or something else that it uses to obfuscate any sort of private information?
yeah, so these are interface protocols that add levels of encryption on top of them. Yeah, from that perspective. And then internally, from a process perspective, you have in the healthcare space, you have what they call medical necessity. So you can only use the data that's medically necessary to the goal that you're trying to pursue, nothing more, nothing less. So in the case of when we built the automated medical record review, you can't go back and look at a person's total history. You only have to look at the history relative to the procedure of the treatment to make a medical decision. And so we have to build that into the system. Now, sometimes a person, that was a recommendation system. So I just want to point out that the system itself was not making a final decision. It was making a recommendation to a clinician, which supervised that decision. So the clinician at that point, whether it's a doctor or nurse, made the final decision. So with that being said, if the medical clinician, medical director, or clinician doctor needed more information to make a medical decision in using that system, they had an option to request that information and they can get it. But again, it only has to be medically necessary. So you just can't open up, if I'm going in for knee surgery, you can't open up my 50-year history of medical records, right, and look at all that. You only have to look at what's relevant to making the decision for my knee surgery.
Case.
Yeah, exactly.
So what I wanted to get into more of the technical aspects of what you do on a daily basis, the ones that what you can sort of speak about. And in my mind, it's sort of like the architecture and things like that. But even if it's something like sort of the goals you're trying to achieve by what you're doing with the models, sort of the same way you spoke about it with your project in healthcare, and then sort of how that's feasible. You talked about sensors, which sort of was an introduction. So you sort of have these sensors, and you have to make sense of these things. But sort of why do you have them, and what are you trying to sense, and sort of if you could build that picture, and then we can talk about sort of how you're making all this possible.
Yeah. So really looking at the goal of trying to implement any autonomous agent, what you want to do is you want to continuously sense your environment. So if you think of the example of like an autonomous vehicle, right? You have vision sensors, you have heat sensors, you have touch and you have those calibration type of sensors. And so you want to pull those all continuously, sense to understand what's going on in your environment, real time, dynamically, right? Those dynamic processes. And that's the same when we look at in a production environment as well. So we have all these different sensors, and we want to understand based on that, hey, is the healthiness of our process optimal, right? To actually build a big product. And so that's what you want to look at from that perspective. And that's what we kind of focus on. So when you have all that information, you're able to detect, okay, we know when this sensor is operating this way, it's healthy, right? It's optimally function versus not. And so then now you have applications of anomaly detection, right, within it. And then based on that anomaly, or based on any, what we say, variations in these sensors or these processes that we're looking at, we can take actions to address that real time, right? And so that's the data aspect of it. And so when we're talking about that, we're talking about in cases seconds and sub-seconds, right? milliseconds, which is very fast because a lot of production environments run that, not all, but a lot of them run. You building cars, you're running real time and things like that. So you have that aspect of. So now you're bringing all that information. And you got to process it through data pipelines. So specifically taking that data, feeding it in, cleaning it, stripping out the noise, if you will, the erroneous data. Sometimes sensors can get, especially in an industrial environment, sometimes sensors can get erroneous data. They can overheat, and you can capture erroneous data. So you got to strip out all that and get to the core of the signal, strip out the noise. So then that we build in data pipelines, and these data pipelines have to run very fast. And some of the technologies that, which is fascinating, I'm still amazed. Some of the solutions that ever, but we're sending these informations to secure cloud environments, and they processing this information in subseconds and seconds. These data pipelines cleansing that data, and then after you clean the data, now you send it to a model, right? Now, so a model can look at that information to make a decision, and once that information is fed into the model to make a decision, at that point, you're sending commands and signals right back down to the production environment to move pieces of equipment. And what's fascinating about that is that the pieces of equipment may be decades old, right? So in some cases they crude, in some cases they not fully digitized. And in some cases, when you do that, you also, from a foundational perspective, have to go to a digitalization effort with your older capital equipment, because they're not designed to be digitized. And so that's really kind of the cycle, if you think about it, taking that data real time, continuously, seconds and sub-seconds, feeding it into this data pipeline that you built. And it could be on-prem or in the cloud. We send ours in our architecture cloud, process that information, send it to a model for real-time quick inference, and send a signal back or commands back to pieces of equipment to control them.
So there are lots of questions there in that pipeline, but the first, we'll start from the beginning, which is this idea of erroneousness in information, especially when you're coming from an analog data set. How are you able to determine what is a spike in information versus something that's, so what is the boundary of error that or within the range of data that not necessarily specifically, but what makes you feel like that the information is incorrect, right?
Yeah.
Is it just...
No, excellent question. So typically what we do is we look at the distribution of the data. So we know what a healthy sensor machine looks like from a distribution of the data. And typically in the industrial space, you have specifications. So you have these specs, you have upper and lower specs, and you know where the boundaries of where that information needs to lie. And when they get out of tolerance, if you will, or out of specifications, then we know we got anomaly problems in that case. So we can basically model the distribution and the behavior of the data, the profile of the data, and determine it based on that.
Okay, and that is quite helpful, honestly. That is really helpful. So we're moving on to sort of like where you're putting the data. So you just said two things. You said on-prem and you said in cloud. You said it can be on-prem. Is there a reason why you prefer or don't prefer cloud? Because I could also see a privacy issue with cloud, that you're outsourcing the privacy in that context. And if people are comfortable doing that, the organization's comfortable doing that, then that's fine. If they have some sort of promise of a positive outcome with privacy, then fine. But there are also situations, it's just, especially with manufacturing, it may just be faster to do it on-prem. So, whether those are the right questions, I don't know. But if, correct me if I'm coming from a different angle than is realistic.
No, I think you're hitting on something that's very important around these architectural type of decisions, like you said, and privacy as well. So in the case of privacy, it really depends on what type of data that you're sending. So to the cloud, right? If you're not sending any of your proprietary secret processes, or you can say your product design specifications. Those are the type of the things that typically manufacturers will not send to the cloud. And even when you build that, when you send in let's say your sensor production data, let's say to a cloud environment, as an example, it's typically a private tenant cloud in that architecture. So it's a private tenant with a secure funnel back to your company. You have those pieces in there, and typically most companies won't put, like I said, a lot of their secrets, proprietary type of information in those clouds environments there. But privacy, to your point, is a real issue when it comes to that, because security is a function of time. Let me just say that. All right, security is a function of time. Yeah, if you got hackers out there, they hack. It's just a matter of time, and you just gotta kind of keep up. And then you can use AI to detect fraud and hackers and things and attacks. And we have applications, and a lot of other big organizations have applications, especially in the financial industry, where you can detect that fraud. We detect those attacks there. Now, coming back to your question on does it make sense to be on-prem versus the cloud? And it really depends on the use case there. So you can push compute to the edge. When we say the edge, that's typically on-prem because you really need that faster response time. You need that faster response time. And depending on how you architect it, right, you can do what they call federated learning, right? So federated learning, basically, you have your main model. Let's say it's in a cloud environment, doing the main inference, and then you have copies of your models on edge devices, let's say on-prem, right? And so it's offline. So the ones on-prem are offline, but as it make inference and as you go through the retraining process and learn, it connects back to that main cloud version of the model, and it learns and it shares each other's learning. And that's a very complex architect and design. I haven't seen a lot of companies, really implemented that yet, that type of design, but that's one way to, if you need that faster sub-second on-prem response time that you're speaking to as well, you can do that right at the edge. So you can have it's right there, it's local. But in my experience of what I've seen and the solutions that we ran in the cloud, even in the healthcare solution, we're talking seconds there, literally to get a response.
So how do you make that delineation? Well, there's a bunch of questions there, and I want to ask them succinctly. What came to mind for me is, how do you create there's a bunch of problems with processing power and all that. I think maybe manufacturing is less of a problem, because you just have this space, quite literally, to say, okay, if you have something, if it needs to be big, it's big, but it's on-prem, and that's what we need, right? But even with that, because there's so much data, there's also a limit to that too, because you need space for the actual machines as well. So there's a bunch of complications there. So how do you, as a person who is in charge, draw a line of like how much power is local, how much power is on the cloud? Because cloud is pseudo infinite and local isn't.
Right.
Yeah. Right. So.
Yeah, good question. So really depends on a couple of things that factor in. Number one, how much existing compute power you have on site. So you look at that, and when you look at that and determine, hey, does it make sense from a capital investment perspective? And this is obviously the management side of working in the AI space. Does it make sense from a capital investment to bring more compute on-prem to support this application versus do it in the cloud? Cloud is a utility-based, usage-based type of model, which actually is pretty, in and of itself, depending on what cloud vendor you use, can be complex in and of itself. And it could be a lot of hidden costs there too as well. But some of those decisions factor in is that to break it over, does it make sense from a cost perspective? Do we have the skill sets to run it on-prem versus, a lot of these new servers require, different kind of skill sets, whether you run it on a Linux operating system versus something else. And then if you run it on cloud, that's also a different kind of skill set, right? Depending on the model, if you want to do a hosted service model, you build and run your own tenant on the cloud, whether it be, Azure or AWS or what have you. So you got to factor in those skill sets, costs, and what you have on-prem from a compute perspective. Sometimes it just may not make sense to add more compute on-prem because it's cheaper to do it in the cloud. And plus, you can buy a hosted service model with that, or you have the skill set in-house to build your own tenant and to run it on the cloud as well. The other complexity that when you're looking at the feasibility of those type of things, the other complexity you got to look at integration. Integration has always been a challenge. It's a challenge in the AI ML space too as well when he's dealing with these hybrid architecture models. So if you have this, this hybrid public cloud hybrid architecture, you got to look at the integration costs. You got to look at the integration technologies. Some of them are mature and others are not mature at all. And do you have the skill set to support that? So those are some of the, when you talk to the architecture and the compute, the factors you get in. The good thing with the cloud, like I said, you can pay as you go, but also could be hidden costs there as well that you have to be aware. Now, NVIDIA, I just want to mention this, NVIDIA have a computing model where they actually still do their compute on-prem for you, and they take care of it all. And there's been studies that they have did that where they have shown with that on-prem compute for you that NVIDIA hosts on your behalf is actually more cost-effective than running in the cloud. So I thought it was some interesting studies and models that they have out there.
Right. Especially with the amount of data you would have to send off-prem in order to be able to, for it to work in principle, especially with something like manufacturing.
Exactly.
I know, with what everything it seems like you're trying to do, you're trying to create your boundary for real world simulation is very high, because you're literally, sensing reality itself, as opposed to like sort of a lot of people who are doing ML models are basically, playing with user inputs essentially, but you're essentially, you're really playing with reality, and there's a lot of data there. To have it sent over a network, that's I would assume it's like could be terabytes of data every like sort of periodically, and that's quite high. So for them to bring it on premise, I didn't know that they had a service that's local for large organizations. So
yeah, I thought it was interesting too. And they say, hey, it's it's cheaper than your cloud. They did some studies. Like, wow, yeah,
makes sense. So what was great is you talked about integration, right? And sort of the concerns about integration, and you alluded to that a little bit earlier with the older machines and what it would mean for those machines to be, change from, or at least integrate with a digital interface, and how that, can be challenging. 60, 70-year-old machines, the people who, in a way, but the people who know the most about them are, have given sort of are no longer here, or it's possible that they aren't. Of course, there's manuals, but lots of people don't like reading manuals, and if they do, it takes a while. So there's lots of complexity. There's actually a story. Yeah, there's a guy there's a guy who he's very successful. I forget his name, but like the way he got into the market and was able to sort of elevate his career is that he worked at a store that managed and took care of HP printing machines, and people asked him how was he so able to accelerate his business so quickly, and he said, I read the HP manual. And when someone asked a question, I would say I would do it and go read the manual at night, and I'd get the answer because nobody wants to read manuals. But anyway, that with that anecdote, sort of as a baseline, sort of how do you actually make this possible with these older machines? It is really challenging to go into something that was made, and with or without a manual, to understand how to make, get this to give you the information you need. There's an expertise issue there, from just like the basics you need to even understand what's possible. And then there's the actual having to reverse engineer, the problem and trying to get a solution out of it. So if you could speak to that'd be great.
Yeah, that's a great question. So typically when you're talking in industrial space, a lot of the older, capital equipment, have been controlled through like PID loops and PLCs, programmable logic units, and those type of things. And they're not devices that have open integration protocols and things like that. So you typically have translators in between to help you translate that. So for example, we couldn't send a REST API call directly to a PLC. It just wouldn't work good because the integration is not there. So we got to have these middle layer translators that exist. And some of the what we call the IoT type of vendors out there, Internet of Things vendor helped us provide those type of technologies that would integrate with these new API calls or these new interfaces back to the older technologies to push some of these things. And so what you're hitting at, Chris, here is what we call the process of digitization, right? How do you digitize some of your older capital equipment, things like that? And that's a huge concern in the manufacturing industry. And so, I learned and employ solutions like digital twins to help in that process. And digital twins
Sorry,
help.
can you say that again?
Digital twins. So digital twins. So digital twins are basically, these are virtual replicas of your production environment. So it takes the data, it contextualizes that in a very meaningful way, where you can basically have a replica of your product, your process, different pieces of equipment. And so you can understand its behavior from a data perspective. And with those type of platforms and tools, it also gives you that integration technology. So now you're interfacing directly with that versus interfacing directly with a device or some translation layer. And so those are pretty powerful platforms like Siemens, for example. They have digital twins in the industrial space. There's other products like BrainCube. There's another one called like Twin Thread. But anyway, they gives you that, it gives you that digitalization necessary so that when we're talking about these AI ML solutions, you can interact with the data in a way that you don't have to build a lot of proprietary interfaces down to these different machines and things like that. So you're digitizing your operations in effect. And so
Right, and saves you a lot of time.
Exactly. Because
in the web world, it's called. Sorry, go ahead.
No, I was just saying is it like I said, because a lot of the old capital equipment is still useful, and if you don't want to replace it, but now you got these translation layers. But there's another challenge with that. We'll talk about that soon. So go ahead.
No, I was gonna say in the web world, it's we just call like a dev and staging environment, and it's the same sort of thing. It's like digital twin. You just sort of have a fake environment where you can play with the information, and that way you don't shut down the company for 30 minutes because you want to make a test. So it's the same sort of thing. So that I was just saying there's parallels all over the place with environments where you have to test for engineering. You have to test your engineering with fake environments.
Digital twins are a little bit more powerful in the sense that it brings together not only the digital aspect of it and the contextualized layer. So it gives you that basically that process view. This, for example, that where you have different sensors taking different data at different frequencies, right? So they just integrate that in a very contextualized, meaningful way. So you don't have to deal with these lags for the different sensors in that. Not only that, it gives you the ability to simulate. So you can simulate your process. You can make process changes. You do what if scenarios for it and see how that impacts your product quality. See how that impacts the efficiency or optimization of your production process. And it comes with that whole suite of analytics. Not only that, so the data is integrated in a very contextualized, clean, denoise way. So that information can be fed into a AI ML model quickly for inference. And so now you don't have to go through, or you can reduce the process of going through doing the data cleanses on the data prep phase. If you think about the AI ML development process, now you can reduce that cycle there versus having to clean it and build a separate data pipeline for it. So there's some clear advantages there in using those digital twins.
That's clear. Yeah. No, absolutely. That's a lot of time saving. Absolutely. Because the data cleansing is quite, that's its own set of issues, right? Like cleaning up that pipeline, making sure you have the right information, making sure it's, like you alluded to, there are no errors. And because the errors come spontaneously in these environments, right? It's not a result of code issues. It's just the sensor has an issue, and that's a spontaneous thing, and it can mess up your data, because getting these models to actually give you the results, it does take time. You have to train it over a period of time, and any error, it's hard to chase down where it was that caused this issue, and it must be quite the challenge. But you did allude to the idea that there are other challenges that come with this. So if you'd like to speak about that, I'd like to hear.
Yeah, as a part of just looking at from a foundation perspective, you got the AI ML that kind of sits on top of the digital foundation. One of the challenges in the industrial space, if you have, capital equipment for, 50, 60 years ago, you can put translation layers in there to get that digital information. But you got to keep in mind that the equipment can only do so much at that point. So you have the actual limitation of the equipment itself. A good
The translation layer or the older equipment?
of the older equipment, the capabilities of the older equipment. So if we want the equipment to do certain things, it may not have, let's say, the memory base to do it, right? Because if we're sending data back to it, sending command, it just doesn't have the memory base. Like, for example, a PLC may only have, let's say, 16K of memory to do something, and so so you have those type of limitations that you have to deal with, and sometimes that necessitate, in this role, say, hey, do we have a business case for capital equipment? Because now we have this barrier that really we can't get to that aspirational aim of getting to autonomous operation because we have these, literally these physical equipment barriers.
There's limitations. Yeah. Is there and this is sort of more on the managerial side, and you sort of alluded to sort of like justification for capital costs. Is there a lot? It's hard to say, but is there a line where you say, okay, we absolutely, because this is not a small thing to replace. This is a multi-million-dollar thing to replace that's been working for 60 years. How do you say to them, hey, you need to spend X amount? This is something that you absolutely must do. And they're like, I really don't want to pull $10 million from the account. And you say you absolutely must. So that's a very hard conversation. That's not, I just want to hire another person. That's a tough thing to sell. So how do you even conceptualize that and justify that? I would assume with lots of reports. First and foremost, the last like 2 pages of reports, 3, 4, 15, 18 pages of reports, which by itself takes quite a few, for quite a few weeks and months.
Yeah. And actually, when you're dealing with that level of capital risk, it should, right? Because we're talking about, major investment. And so, one of the things that, I tried to do in working with the executive to show them that, okay, this is the goal. This is where we want to get to. In order to get there, these are the type of tools, the type of capabilities we need in place. And, you can build a business case purely on new capabilities to get you to your strategic aim. And I have did that a lot of times throughout my career. A lot of it, I work with newer technologies. And so the return is not that clear. So it's high risk, high reward. And so those are the type of, those are the really hard business case to come across, because if you're dealing with finance and accounting, they want to know, hey, what's the cost savings? And that may not be clear. We all understand that. But at the same time, we also know that in order to stay viable in the market or the industry you in, you have to place strategic bets. And we know that some of them are not going to pan out. Most executives understand that. And then you have to deal with the culture itself. Do they have a tolerance for high risk, high reward, or they're more conservative when it comes to these type of investments? So you have to deal with the dynamics of all that in order to be successful. And I would tell you that I probably mentioned maybe one time in my career, once out of all these 20 plus years, I took a business case through, and the actuarial team, they audited it. They was like, this is solid. Go do. They gave the thumbs up approval. The chief medical officer was on board, and we took off. And that was in the case of when we did the medical records automated review process. We had actuary review those numbers. And when you scale it out, it came to be basically a 46% return on investment. Over time, we were able to bend the cost curve. What does that mean, bend the cost curve? Typically, when you do more reviews, utilization reviews, they call them, for hospitals, for employer groups, you need more people to do it because the clinicians do the reviews. So we're able to do that with less. So it's a linear relationship. So the more reviews, the more people you need. So we took that and we bent the curve with this. And over 3 years, I think it was projected to be 3.8 million in savings. Just for that, yeah.
Nice.
So that was a clear, that was the clear-cut case. And sometimes in a case when you're dealing with new capabilities, you arguing based on the fact that think about roads and highway systems, right? How do you do a return on investment on that. You know you need it, you understand it. Just think if you don't invest in those roads, those bridges and those roads and that infrastructure, it's going to come back to haunt you anyway. And so sometimes you got to justify, those foundational pieces just like that. And it takes some time. You're right. It's not an easy sell. People look at different things, and you got to consider the dynamics of the environment. Find a sponsor there that really believes and sees the vision that's credible and powerful, and that can help you move things forward.
Yeah, that sounds. I mean, even the example you gave, it was still sort of a cost cut, because cost cutting, everyone is. It's not that everyone's on board, but it is something that people are more likely to move forward. But once you have, and the real stuff that's really powerful is, when you're doing something experimental where you're trying to capture more market share, and that's almost impossible to sell because it is so speculative, right? So it takes quite a lot of nuance to be able to push this kind of stuff forward. But you've been doing it for quite a long time, for 25 years, so somebody can do it, right? So we'll move a little bit from more, I would say more fun topic of sort of like speculative behavior and sort of technical know-how and being able to, sort of decide where compute is and sort of selling it to higher level stakeholders. A bit that is again that's sort of like that's also sort of more risk reward there where you're selling it to those guys. But it can be fun to something that might be and you tell me, a little bit more frustrating where you have, especially in the manufacturing industry. And I'm not sure if you have had to do this, but you have to upskill traditional manufacturing workers, trying to get them to convince them that this machine learning model, first of all, communicate that what a machine learning model is, and then convince them it's a net positive outcome for them and their work, and then also then objectively get them to actually contribute and not sabotage the endeavor, because if people doesn't want to do something, they won't do it. So that's quite the sell on that side. So how was your experience with that?
Yeah, that's a great question. That speaks to the organizational change, right? When you and manufacturing in general and industrial space, they laggers when it comes to technology. So they're not typically on the leading edge when it comes, like you see in the tech firms or maybe financial services or those type of things. And one of the things in working with, because I actually run the community of practice, one of the things that you find with people, especially people who've been in the environment for many, many years, they tend to have manufacturing typically, in general, not all, but in general, they typically have a longer term employees that's been there for decades. And so change can be very scary for them, right? And that's probably based in a past experience of working with different initiatives at the company and things like that. Sometimes, being new, especially in my role at Tamco, I don't have that baggage, if you will, but I have to understand that history. So typically, it's when you're dealing with that, and it's also true with doctors and nurses. But when you're dealing with that, you're dealing with lack of understanding, right? How do you get somebody to understand that these new capabilities and tools are not here to replace you, but to actually help you be a better engineer or operator, on the floor, right? Make your life easier. There's some things that you probably, some pain points and some things that you hate to do. How can we make this technology eliminate that from your daily, workflow or your daily responsibilities, and getting them to get to trust it. That's the other piece. How do you trust it? And trust comes with understanding how it works and why it's doing what it's due, and you can see it. Getting them involved up front, early and often as you can, so that they can understand the development process too. And then once they understand and they involve, they start taking ownership of it. You start seeing ideas flow from them. Like, hey, what if we can do this? I think it's, my experience in working with technology and people, I think it's naive for, any IT department or data science team, or let's say AI ML team like my team, to come into the picture and think that, we know all the answers. We don't. So we have to work with the experts, the people who've been doing it for many years, to understand, their workflow process. You can build the the best solution in the world, but if it doesn't integrate into somebody's daily workflow process, they're probably not going to use it. If they don't trust it, they're probably not going to use it, right? They don't understand it, they're probably not going to use it. And so that's a part of the challenge, is getting them engaged, helping them to understand, and explain in a way they can receive it. We're talking about people who doesn't have master degrees in data science, right? And how do you explain it in a way that's meaningful and impactful to them? So, for example, one of the things that we try to do through our community practice, we have hands-on sessions, just explain, hey, what is a predictive model? What is it? What can it do for you? What is explaining these terms of, like, what is data engineering? Signal. Now, I'm happy to say our community practice, our engineers, they understand signal. They understand that, hey, I have to, once I iterate and I'm building a model, I have to find signal that's good enough to predict what you want it to do. If you can't find the signal or the relationships in the data, then, you might as well stop the project and move on, those type of things. And so, we try to teach those concepts. And also we teach, what is data engineering? A lot of people don't understand. That's fundamental to machine learning in particular. Yeah, what is that? It's simply that you transform the data, you clean it up. We operate with the assumption that all data is dirty until proven clean. We teach them that concept. And once it's clean, it's ready for modeling, those sort of things. And you got to go through an iteration cycle. So we involve them in some of those details. The people who want to jump in and embrace it, they will. You're always going to have the naysayers on the fence. They basically, over time, they're basically gonna wash out anyway, or retire, whatever the case may be. But it's a cultural change, especially in the industrial space and manufacturing, because they tend to be laggards when it comes to this more advanced technologies. But that's a part of it. You have the system aspect, but introducing value-added change is also just as much as about the people and getting them to trust, to augment their workflows, and to reduce that fear of, hey, is it gonna, here's the 500-pound gorilla in the room, is it gonna take my job? No, we're here to, augment it. That's right, exactly, and upskill. So that's why we're in this process upskilling. So you can also know how to apply this application, these tools to your daily job as well.
Well, Carl, thank you so much. I mean, it's been very, very informative. I really do appreciate it,
Yes.
And I do hope you could come back again. And but before that, if you want to reach out to you, find out where you are, maybe learn some more, how can they do that? How can they how can they reach out to you?
Yeah, so they can reach out to me via LinkedIn. I pretty much stay active on LinkedIn. Right. That's my main form of social media. I don't mess with Meta or Facebook and things like that. But you can definitely reach out to me on LinkedIn if you want to know. And I typically do a lot of different virtual conferences and things like that. So you'll probably see me in the near future doing some of those two talks about just my experience and collaborate with other AI ML professionals, because that's how I learned too, Chris. So I'm very super excited to have this conversation with you. And to stay in your collaborative network of professionals as well.
Thank you so much. Really appreciate it. Thank you for giving us your time. It was amazing. Thank you so much.
Thank you. Have a great rest of the day. Take care.